Good day, friends. Welcome to Prolific Online Maths. Today, we shall be looking at indices. Our topic today is indices. And as you can see, like I said, and I've always been saying it, that mathematics is a subject of numbers. You deal with numbers and you operate with numbers. We only use words to express or interpret the numbers. So today we are looking at indices. But before we go into the topic proper, let me just introduce you to the word indices. Indices is a plural of index. Is a plural of index. Index. The word index means power. Power. And the plural is indices, which is singular. Singular. And the plural is indices. Indices, which also means powers, which is plural. So the plural of index is indices. So when you're talking about indices, you're talking about power, using number with power. And what does power means? For example, if you are given a number like this, 2 raised to power 3, 2 raised to power 3. This is written in index form. This is written in index form because this 2 is carrying the power of 3. And what this one simply means is that 2 is the base, while 3 is the index or power. Index or power. So what this one is translating to is 2 in 3 places, multiplying 2 in 3 places. That is why it's being referred to as index. So you express this particular number 2 in index form. So this particular number is in index form. 2 is in index form. So 2 into power of 3. It means you multiply 2 in 3 places. So 2 is the base, while 3 is the index or the power. So when they are more than 1 or 2, you refer to them as indices. You refer to them as indices. So this is indices. This is indices. So we are going to look at how to solve problem of indices. We are looking at how to solve problem of indices. Thank you. Let's move on. Now, before we can proceed on this topic, we need to understand the rules that govern this topic, which is the rules of indices or the laws of indices. And what are the laws of indices? Laws of indices are many. There are many, but we are going to divide them into different sections, and we are going to have some examples on each of those rules or laws so that we can have better understanding of the topic proper. Thank you. So we are moving on to the rule of law, the rule of indices, having explained the background of the word indices. So today we are looking at the laws or rules of indices. Laws or rules of indices. Laws or rules of indices. The first on the list is the product law or rules. Product law or rule. Product law or rule. And what does it say? It says a raised to power x multiplied by a raised to power y is equal to a raised to power x plus y. Simply put, when you are having and you're having indices like this, an expression like this in indices. What it simply means is that since they are having the same base and different indices, you give just pick one of the base and you add the indices. Add the indices, that is, you add the power. Pick one of the base because they are having the same base. So pick the two powers, then add the powers. So it will give you what you are looking for in this law. So simply put, when you are having indices written in this form, pick the base, they are the same, then add the indices. Now let's let's apply this. If you are given 2 raised to power 3 multiplied by 2 raised to power 2, by this law or this rule, it simply means since they are having the same base, you pick 2 and you add the indices 3 plus 2, which will give you 2 raised to power 5. That's all. It is as simple as that. So this is the first law. You can see this is times. Multiplication also means product. So you can say multiplication law or product law. So when you're having a multiplication law like this, it simply means you pick the base. Since the bases are equal, then add the indices, just like the explanation I give you here. Also, if you're having y raised to power 2 multiplied by y raised to power 6, this is the same thing as y raised to power 2 plus 6 is equals to y raised to power 8. Answer. So we have expressed this formula, this rule, by using these two examples, and as we can see, we arrive at these answers. So this is the simplest way of expressing this law or applying this law here. Then the second one is the one we call division law. Division law or rule. Division law or rule. Division law simply says a raised to power x divided by a raised to power y. So is equal to, they are having the same base, you pick the base and you subtract the indices. You pick the base and subtract the indices. As you can see, x, a raised to power x divided by a raised to power y equals to a, since they are having the same base, so a raised to power x minus y. So you subtract the indices. So by application, if you are having 2 raised to power x, 2 raised to power 3 divided by 2 raised to power 2. So this is same thing as 2 raised to power 3 minus 2, which is equals to 2 raised to power 1, or you can simply write 2. That is our answer. So this is divisional law of indices. So when you have a division, you have to subtract the indices. When you have a division, you have to subtract the indices. So this is divisional law of indices. That is the second rule of indices. So we move on to the third rule, which is power rule. Power rule. Power rule is the third rule. What does it say? It says a raised to power x, close bracket, raised to power y is expressed as a raised to power x multiplied by y, which is equals to a raised to power xy. So the power rule says a raised to power x open bracket and close the bracket, raised to power y, it can be interpreted as a raised to power x multiplied by y, which will give us what? A raised to power x y. By implication or application, we can say a raised to power 2 raised to power 3 is equals to a raised to power 2 multiplied by 3, which will give us a raised to power 6. So we've arrived at that. And even if you're having multiple numbers like that, suppose you have something like a raised to power 2, close bracket raised to power 3, close bracket raised to power 4, close bracket raised to power 5. What you have to do here is simple. Just say a raised to power 2 multiplied by 3 multiplied by 4 multiplied by 5. Then you will have to arrive at your answer. 2 times 6, 3, 6, 6 times 4, that's 24. 24 times 5, that is 120. That's the answer. So whenever you have issues like this, just go straight and multiply them out. So this is a power law. Power law. The fourth one is what we call the zero law of indices. Zero law of indices. Zero law. Whenever you see a letter or a number that is raising 0 as its power, it simply means in indices that number is equal to 1. Any letter or number that has 0 as its power is equal to 1 according to the law of indices. So this is a raised to power is 0 is equals to 1. P raised to power is 0 is equals to 1. 1 million or 100 raised to power is 0 is equals to 1. That is what the law of indices is. That's why you call it zero law. So when you have a 0, when in indices, any letter or any number that is carrying 0 as its index or have 0 as its index is equal to what? 1. So a raised to power 0 is equals to 1, and the p raised to power 0 is equals to 1. 100 raised to power 0 is equals to 1. Whatever number that raised to power 0 will give you 1. That is the zero law of indices. And that is what we are going to learn on this law. We still have the other ones. That is what we call the root law of indices. Root law. Under the root law of indices, you can call it root or fraction. Fractional law of indices. Fractional law. Because you can express some root in form of fraction. So that's why I slash it with a fractional. So if you're having a root a, what this one is saying is you should look for a raised to power 1 over 2. That's what this one is saying. So root a means a raised to power 1 over 2. And if you're having cube root of a, it simply means a raised to power 1 all over 3. So that's why I call it fractional law. So you can see that this power is in form of fraction. It's different from x and y, 2, 5 and all that. So this one is actually having the fraction. So if it is like this is quad root of a. It simply means a raised to power 1 all over 4, which you can express like this. Also, if you are having it like this, it can also be expressed as a raised to power 1 all over 5 and so on. So I mentioned they are roots and they are also a form of fraction. So by application, we can also have something like this also. 1 all over root of a. 1 all over root of a. You can express this as a raised to power minus 1 all over 2. A raised to power minus 1 all over 2, which is you can express like this. This can be like this and this can be like this. Also, if you're having 1 all over the cube root of a, is still the same thing as a raised to power negative 1 all over 3. So this is negative aspect and these are the positive aspect, and so on and so forth. So all these are fractional laws of indices, and you can also call them root laws of indices. So this is applied to all indices questions we come across. Let's proceed with some examples on these laws. Having explained the basic laws of indices, we are moving on to solve some of the examples, few examples on indices. Simplify the following. S raised to power 9 multiplied by s raised to power 5 multiplied by x raised to power minus 2. Simplify x raised to power 9 multiplied by x raised to power 5 multiplied by x raised to power minus 2. Now, going by our formulas and laws that we have explained before now, we just say, since they are having the same base, x raised to power 9 multiplied by x raised to power 5 multiplied by x, because of this negative sign, we can express this as 1 all over x raised to power 2. You remember why this one is like this? You know, I told you that 1 a raised to power 1 like this can be expressed as what? 1 all over a. So anywhere you see a raised to power minus or negative 1, you can also express it as this. So this is what we are expressing. And under our product, I mean our root law, we also have 1 all over root a can be expressed as what? A raised to power minus 1 all over 2. So when we are having x raised to power minus 2, it can be expressed as this. It can be expressed as that. Now, moving on. X raised to power 9, because of the multiplication sign, this will give us plus 5 multiplied by 1 all over x raised to power 2. So this is same thing as all over 1. Let me write it very well so that we can see. X raised to power 9 plus 5 multiplied by 1 all over s raised to power 2. This is equals to x raised to power 9 plus 5 will give us 14. Then x times 1 will give us s all over x raised to power 2. So this can be expressed as x raised to power 14 minus 2, which will give us x raised to power 12. How did we arrive at? You know, this has become a division, and I've told that when you're having a division law, you have to subtract the indices. Under division law, you have to subtract the indices. This from here can be expressed as x raised to power 14 divided by x raised to power 2. The same thing as x raised to power 14 divided by x raised to power 2, which is equal to x raised to power 14. And when you're having division, you have to subtract the indices minus 2, which will give us x raised to power 12. Answer to that. So we have been able to solve that in this form. So I'm only trying to express this so that we can have better understanding of how we are applying our laws or rules of indices. So that is that on that. So we simplify that. So example 2, if we are to simplify this, simplify 4 raised to power 5 multiplied by 4 raised to power 0 multiplied by 4 raised to power 9. 4 raised to power 5 multiplied by 4 raised to power 0 multiplied by 4 raised to power 9. How do we solve this? As you can see, they are all having the same base. This can be solved by 4 raised to, just like I said, this is 4 raised to power 5 multiplied by 4 raised to power 0 multiplied by 4 raised to power 9. Now this can be solved by applying our laws of indices that we have treated earlier. And as we can see, a particular number here, number here is having power of 0. And like I said, any number that is having power of 0 is equal to what? 1 under the law of indices. So here we are going to have 4 raised to power 5 multiplied by 1 multiplied by 4 raised to power 9. So 4 raised to power 5 times 1 times 4 raised to power 9. So, and we can see that they are having the same base. So 4 raised to power 5 plus 9 multiplied by 1. This 4 and this 4 carry 5 and carry 9. They are the same. So we bring the indices together and add the indices. So this will give us 4 raised to power 5 plus 9. So which will give us 4 raised to power 14 multiplied by 1, which will give us 4 raised to power 14, which is our final answer on this case. Now, moving from here, we want to look at some other aspects of indices, or we can call it some other cases. It's a bit hard, but we need to express some things before we move on to that. If you are asked to simplify a number like this, simplify 2 all over 3, open bracket, close bracket, raised to power 2. You can express this as 2 raised to power 2 all over 3 raised to power 2, because these 2 outside the box belongs to both 2 and 3. So whatever that you are going to use these 2 to solve is applied to 2 and 3. And by so doing, this is what it means: 2 multiplied by 2 all over 3 multiplied by 3, which will give us 4 all over 9. So we simplify this by using this method. And also, if you're having 2 all over 3 raised to power minus 2, let's look at this. This is carrying a negative 2, different from just the positive 2 here. So you can express this in 2 ways. You can express this in 2 ways. First, you can say 1 all over 2 all over 3 raised to power 2. You express it like this, which is written as 1 all over 2 raised to power 2 all over 3 raised to power 2, which is equal to 1 all over 4 all over 9. Then you express that 1 all over 1. You separate the fraction. This fraction, 1 all over 1 divided by 4 all over 9, which will give you 1 all over 1 multiplied by 9 all over 4. Your answer will then equals to 9 all over 4. You can leave your answer like that. You can leave your answer like that. Another way, or in law of indices, when you're having A all over B raising to the power of negative like this, you can simply say or express like this: B all over A. There will be an inversion. We call it inversion. So B will go up while A will come down. The fraction will what? Will change. So the numerator will become the denominator and the denominator will become the numerator, which we can also express here. So if we apply this here, this will give us 2 all over 3 raised to power negative 2 is same thing as what? 3 all over 2 raised to power 2. The fraction has been what? Inverted. So we have converted the numerator to become the denominator and the denominator to become the numerator. So we can now express further and say 3 raised to power 2 all over 2 raised to power 2 will give us 9 all over 4, which is the answer we also got here. So all these are some of the ways we can solve problem of indices. All these also are what? Are also part of the solutions we are going to get in indices. As you can see, we move on from here to the next